Good day, ladies and gentlemen. You're all very welcome to this week's CNPS technical session, hosted by me, Ian Cowan. We're delighted now to resume the 8-part series, which is being given by Vladimir Netchitailo on his Hypersphere world universe model. We had his part 2 actually almost a month ago now, which dealt with multi-component dark matter. So today we're going on to part 3. But just before introducing the meat of the subject today, I'll just, with your perseverance, play again the very short video which has been recorded by the CNPS president, David de Hilster, on the funding plea, because as I think most of you will know, the income that the CNPS derives from membership doesn't actually fully cover the running costs. The server and the whole StreamYard business is actually quite expensive. So let me just play this. We get it out of the way. Let me see now. Here it is. So there. It takes just 1.5 minutes.
Hello, my name is David de Hilster, and I'm president of the John Chappell Natural Philosophy Society. Our organization is unique in the world in that we allow for serious criticisms of mainstream science, from physics to cosmology and from math to philosophy. And today, this organization resides 100% online. If you enjoy our Saturday morning talks, our websites, and the community of amazing critical thinkers you can interact with on the internet, then please consider contributing to our annual fund drive. It costs almost $3,000 per year to keep our internet presence and our Saturday morning talks alive and well. I want to thank all of our members who pay monthly and annual memberships, which is vital to our day-to-day operations. But unfortunately, this is not enough. And that's why we're looking to raise $2,000 in our 2024 drive. So if you don't want this organization to disappear and you think that its mission is important, then please consider donating to the CNPS. It's vital to keeping science moving forward. Please go to fund.naturalphilosophy.org and donate today. Thanks once again from all of us at the CNPS. Your donation is vital.
Right. Well, 2 weeks ago, during the last session that I moderated, we had Stefan Gift talking to us, and it was the most interesting lecture. It was the second lecture that he's given to us on this subject of Solari transforms and so on. But we had a couple of unfortunate acts of God, if you like. One is we ran out of space, so that the recording after 36 minutes cut out. Now, we've investigated that, and it seemed to be that there's sort of a toggle on the StreamYard that one can set, which we're continually using space, and when it runs out of space, well, if this toggle is set, it will automatically delete the most ancient recordings so that we have space. And that wasn't set, but that's now been set by David. Now, actually, that doesn't mean that the YouTube recordings will be deleted. We have those for all time. It's just that in order to put them onto the StreamYard prior to transferring them to YouTube, we need that toggle set. So I trust that will not happen again, that problem. I suppose a bit optimistically, we are hoping that not only because of the value of the lectures in real time and the engagement of people on the social media and the green room and so on, gets us thinking, and in the immediate future maybe spurs on some work, but we sort of hope that for all times people might want to come back to these recordings maybe in months or years time and say, goodness me, what did Vladimir Netchitailo say about that, about angular momentum or something? And, we'd like to have it recorded. There was another slight unfortunate circumstance. We seemed to be jinxed a bit 2 weeks ago in that the social media, Facebook and YouTube systems went down again, somewhat what through maybe halfway through the proceedings. So people couldn't participate after that, and I hope that hasn't discouraged you. Yeah, there's one more thing I have to do, and it's very important. I have to get today's link, and I'm just copying and pasting. Just you bear with me. I'm copying that, and I'm going to paste it into the not the private chat, the comments, so people can know if they need to get into the green room. I'll just say GR and get people know what that means. Okay, so that's that. That's that done. Now, yeah. By the way, just before I leave the funding business, Franklin, who has put in a note, he says we've reached 70% of our $2,000 goal. Please help us reach our goal. Well, that's good in a way. I mean, it's bad in that we haven't reached it, but it's good in that we've got 70% there. And just if we have a few more contributions, we'll probably reach our goal. And then David and Franklin will say you can stop playing that at the beginning of the sessions. So hopefully by the middle of this year we'll have reached our goal, €2,000 goal. Yeah. Okay. Right. So the part 3 of the Hypersphere World Universe model, which is will be delivered by Vladimir, is concerned with actually what he said to me privately is perhaps the most important aspect of this whole subject, angular momentum, angular momentum and the formation of macrostructures. So, and we're getting people coming in now, which is good. So just pardon me to check that. We have a number of people in the green room. Right. So, he'll be discussing angular momentum, the problem in cosmology, introducing what he calls the Dark Epoch, which is spanning from the beginning of the world, 14.22 billion years ago to 0.45 billion years ago. I know not all of us agree with that, but this will be the subject of discussion, no doubt, later on. He says when only dark matter macro objects existed in the medium of the world, and what he calls the luminous epoch, as distinct from the dark epoch, ever since the 3.77 billion years. He proposed an explosive volcanic rotational fission model, which is responsible for transition from the dark epoch to the luminous epoch. Okay. So yeah. Okay. Well, I said some of us, don't even countenance this Big Bang initiation of the universe at all. But it appears, and Vladimir will clarify this, no doubt, that he might be talking about the period just prior to what's conventionally believed to be the origin of the Big Bang. He's going back a little further. He'll discuss the formation of macrostructures. He'll provide an experimental results of the JWST, the James Webb Space Telescope, and their explanation. He'll discuss galactic rotation curves by mass currents without DM dark matter halos. He'll stress decisive role of gravitational parameter large G, the Newtonian constant in cosmology. So there's a lot of material there, and I won't take any more time because I know Vladimir is very cognizant that he likes to get through everything, but he likes to give us plenty of time to talk. In fact, I think he likes to follow the rough 50-50 division. But there's absolutely no problem if he needs a little more time than half the time. Please, there's no problem at all. Please go on. So there's Vladimir. Vladimir, you're up now, and again, you have written material there that I think you want to go through, but I think you normally project it, don't you?
Yes, man.
So, do you want to share your screen?
Yes.
So I'll stay up here just to make sure everything is all right. Yeah. Okay. Just see if there's anything urgent coming in on the comments. Yeah. Okay. Oh, yeah, I've got it here. So I have to put it up physically. So there it is. And what I'll do, if this is agreeable, is I'll disappear now, but I'm available. Just call me if you need me. And I'll then try to remember how Franklin showed me how to maximize the screen so that your photograph goes off, but we still hear you. Okay?
Okay.
So the floor is all yours now.
Hello, everyone. Thank you for coming. Let's start. First of all, I would like to stress that a hypersphere is an example of a three-manifold which locally behaves like Euclidean 3D space, just as a sphere looks like a plane to small enough observers. In classical physics and our everyday life, we use alleged space 3D Euclidean and solar time t. My model based on cosmological time tau that is defined by impedance, wave resistance of the medium that equals to Hubble's parameter h. Cosmological time is inversely proportional to h. It marches on at a constant pace from the beginning of the world up to the present epoch, along with time-varying cosmological parameters, and defines the absolute age of the world. Time is not a physical dimension and is absolutely different entity than space. Time is a factor of the world. Let me remind you the main results of the second presentation, multi-component dark matter. Critical energy density of the world can be found by the Hubble's law only. There is no need in general relativity. Medium consists of stable elementary particles, protons, electrons, photons, neutrinos, and dark matter particles. The relative energy density of ordinary particles, about 4.8% in the medium, which was experimentally measured by fast radio bursts, 2.4% in macro objects, and the rest, 92.8%, is the relative energy density of dark matter particles. What else could be? Multi-component dark matter system explains a diversity of very high energy gamma ray sources in the world and the diversity of dark matter cores of macro objects of the world, superclusters, galaxies, and extrasolar systems, which are fermion compact objects and dark matter reactors in our model. Binary discovered by Giovanelli and Haynes in 1989 and by Minchin et al. In 2000. Prediction of John Michel of the existence of dark stars is valid for dark galaxies also. There is no need in dark matter to explain galactic rotation curves. It might be the explanation by Ludwig, the gravitomagnetic field produced by the mascaras, and the Hilster, who calculated the rotational curves as a disk instead of a sphere. Unidentified infrared emission bands around peaks at 3.3, 6.2, 7.7, 8.6, 11.2, and 12.7 micrometers, which are the fingerprints of all galaxies, explained by the self-annihilation of dark matter particles DMF4 with rest energy 0.2 electron volts instead of the polycyclic aromatic hydrocarbon molecules, not a single member of which had been identified in space definitively for 45 years observations until now. 21 centimeter emission with the broad line width explained by the self-annihilation of ensemble of ultra-relativistic dark matter particles xions instead of the forbidden transition in neutral hydrogen atoms for which there is no explanation for a mechanism of their production. Dark galaxies are made of dark matter particles only. Angular momentum problem. Angular momentum problem is one of the most critical problems in standard cosmology that must be solved. Professor Leon Mestel, in his paper on star formation in Quarterly Journal of the Royal Astronomical Society in 1965, realized the full extent of the angular momentum problem. It was found that the angular momentum of a protoplanetary disk is misappropriated when compared to models during stellar bursts. Sun and other stars are predicted by models to be rotating considerably faster than they actually are. Professors Colgate and Petchak from Los Alamos Science, in article Angular Momentum, the Cosmic Pollutant, wrote, there seems to be too much angular momentum in the universe to allow the formation of stars or the accretion of matter onto variable X-ray sources. This fundamental problem begs for solution. When we have too much of something and cannot find a way of getting rid of it, we often think of it as a pollutant. In the game of concentration and collapse of matter in the universe, from clouds of gas to clusters of galaxies, stars, planets, and black holes, angular momentum is the pollutant that prevents the game from being played to the absolute limit, namely collapse onto one awesome black hole for each cluster-sized cloud condensed from the early universe. It is so simple to name something, I mean angular momentum problem, as the pollutant, and then forget about it. And this is the cosmological science. It's unbelievable. In my opinion, angular momentum problem is the killer of all existing cosmological models, including Big Bang model. All timers of cosmology should solve this problem. To the best of our knowledge, the modified in 2018 Hypersphere World Universe model is the only one cosmological model in existence that is consistent with the law of conservation of angular momentum. I absolutely agree with Richard Feynman, who said, "It doesn't make any difference how beautiful your guess is. It doesn't make any difference how smart you are, who made the guess, or what his name is. If it disagrees with experiment, it's wrong. That's all there is to it." Short history of solar system formation. The most widely accepted model of solar system formation, known as nebula hypothesis, was first proposed in 1734 by Swedenborg and later elaborated and expanded upon by Kant in 1755. Can you believe it? About 300 years it was proposed, this model, and still there is nothing principally new. It maintains that 4.6 billion years ago, solar system formed from the gravitational collapse of a giant molecular cloud, which was light years across, with a certain amount of angular momentum. Where it came from? Most of the mass collected in the center, forming the sun. The rest of the mass flattened into a protoplanetary disk, out of which the planets and other bodies in solar system formed. The nebula hypothesis is not without its critics. In his The Wonders of Nature, Farrell outlined the following counter-arguments. It contradicts the obvious physical principle that gas in outer space never coagulates, it always spreads outward. Each planet and moon in solar system has unique structures and properties. How could each one be different if all of them came from the same nebula? A full 98% of all the angular momentum in the solar system is concentrated in the planets, yet a staggering 90.8% of all the mass in our solar system in the sun. Jupiter itself has 60% of the planetary angular motion. Evolutionary theory cannot account for this. This strange distribution was the primary cause of the downfall of nebula hypothesis. There is no possible means by which the angular momentum from the sun could be transferred to the planets. Yet this is what would have to be done if any of the evolutionary theories of solar system origin are to be accepted. Speaking of the mass angular momentum problem, Bergamini says, a theory of evolution that fails to account for this peculiar fact is ruled out before it starts. Lunar origin fission hypothesis was proposed by Darwin in 1879 to explain the origin of the moon by rapidly spinning Earth, on which equatorial gravitative attraction was nearly overcome by centrifugal force. Wise made a detailed analysis of this hypothesis in 1966 and concluded that it might seem prudent to include some modified form of rotational fission among our working hypotheses. Solar fission theory was proposed by Jacquard in 1951, who stated that the planets were expelled from the sun one by one from the equatorial bulge caused by rotation. One of these planets shattered to form the asteroid belt. The moons and rings of planets were formed from the similar expulsion of material from their parent planets. Von Flandern extended this theory in 1993. Flandern proposed that planets were expelled from the sun in pairs at different times. 6 original planets exploded to form the rest of the modern planets. It solves several problems that standard model does not. If planets fission from the sun due to overspin while the protosun is still accreting, this more easily explains how 98% of the solar system's angular momentum ended up in the planets. It solves the mystery of the dominance of prograde rotation for these original planets, since they would have shared in the sun's prograde rotation at the outset. It also explains coplanar and circular orbits. It is the only model that explains the twinning of planets and moons and difference of planet pairs, because after each planet pair is formed in this way, it will be some time before the sun and extended cloud reach another overspin condition. The outstanding issues of the solar fission are: it is usually objected that tidal friction between a protoplanet and a gaseous parent, such as the protosun, ought to be negligible because the gaseous parent can reshape itself so that any tidal bulge has no lag or lead and therefore transfers no angular momentum to the protoplanet. The world exists no energy to allow for planetary explosions. Neither Jacquard nor von Flandern proposed an origin of the sun itself. It seems that they followed the standard nebular hypothesis of formation of the sun. In Hypersphere World-Universe model, we concentrate on furthering a solar fission theory. What else we can use? That's it, what we have in literature right now. Explosive volcanic rotational fission model. This is the name of our model. To be consistent with the law of conservation of angular momentum, any theory of evolution must answer the following questions. How do galaxies and extrasolar systems get their substantial orbital and rotational angular momentum? How did Milky Way galaxy give birth to different extrasolar systems in different times? The age of Milky Way is about the age of the world. What is the origin of Milky Way's huge orbital and rotational angular momentum? We must discuss the beginning of Milky Way. The oldest star in Milky Way, Methuselah, is nearly as old as the universe itself. How did it happen? The beginning of solar system was 4.57 billion years ago. What is the origin of solar system rotation and orbital angular momentum? We must discuss the beginning of solar system also. Wang et al. In 2021 made a great discovery. Most cosmological structures in the universe spin. All the structures in the universe form on a wide variety of scales, from small dwarf galaxies to large superclusters. The generation of angular momentum across these scales is poorly understood. We must discuss the beginning of the world. Rotational fission. In our opinion, there is only one mechanism that can provide angular momentum to macro objects: rotational fission of always spinning, surface speed at equator exceeding escape velocity, prime objects. From the point of view of fission model, the prime object is transferring some of its rotational angular momentum to orbital and rotational momentum of satellites. It follows that rotational momentum of prime objects should exceed orbital momentum of their satellites. In frames of womb, prime objects are dark matter cores of superclusters, which must accumulate tremendous angular momentum before the birth of the luminous world. It follows that a long enough time period must elapse. We named this period Dark Epoch. In 2018, we modified womb the following way and gives a principally new picture of the world. Womb introduces Dark Epoch, spanning from the beginning of the world, 14.22 billion years ago, for 0.45 billion years, when only dark matter macro objects existed in the medium of the world, which we discussed in presentation 1, and luminous epoch ever since for 13.77 billion years for Laniakea supercluster, when luminous macro objects emerged due to the rotational fission of superclusters dark matter cores and self-annihilation of dark matter particles. Main players of the world are superclusters dark matter cores, which accumulated tremendous rotational angular momentum during Dark Epoch by absorbing dark matter particles from the medium inside of rotating dark matter cores. Their self-annihilation at each point of course generates gamma quants and clouds of different particles, atoms, ions of ordinary matter as the result of interaction of very high energy gamma quants with the surrounding particles of ordinary matter. These particles have large linear momentum in all 360 degrees. Particles with momentum directions along of course axis of rotation leave them into medium. This is a supercluster's wind analogous to stellar and galaxy winds. Particles with momentum directions perpendicular to core's axis of rotation have different momentum depending on their directions. Particles with momentum p plus, along with local rotating speed v local, have a some speed larger than particles with momentum p minus against v local. It means that the core has additional angular momentum according to the equation. where parameters are vectors and r local is a radius vector of the discussed local point from axis of rotation. The accumulated by dark matter cores of superclusters rotational momenta transferred to dark matter cores of galaxies as the result of their rotational fission. The experimental observations of galaxies in the world show that most of them are these galaxies. These results speak in favor of the developed rotational fission mechanism. Milky Way's dark matter core was born 13.77 billion years ago as the result of rotational fission of Virgo superclusters dark matter core. Dark matter cores of extrasolar systems, planets, and moons were born as the result of the repeating rotational fissions of Milky Way's dark matter core in different times, 4.57 billion years ago for solar system. Macrostructures of the world form from the top superclusters down to galaxies and extrasolar system. Multi-component dark matter. WUM proposes multi-component dark matter system consisting of two couples of co-annihilating dark matter particles, a heavy dark matter fermion DMF1 and a high-spin zero boson Dirac that is a dipole of Dirac's monopoles with charge mu equals E over 2 alpha. E is an elementary charge and alpha is a dimensionless Rydberg constant. A heavy fermion DMF2 and a high-spin zero boson LO that is a dipole of preons with electrical charge 1/3 of E, self-annihilating fermions DMF3, DMF4, and boson Xion. The reason for this multi-component dark matter system was to explain the diversity of dark matter cores of macro objects of the world, superclusters, galaxies, and extrasolar systems. We discussed this multi-component dark matter system in presentation 2. Macroobject jet model. In WUM, macrostructures of the world, superclusters, galaxies, and extrasolar systems have nuclei made up of dark matter fermions, which are surrounded by shells composed of dark matter and baryonic matter. The shells envelope one another like a Russian doll. The lighter a particle, the greater the radius of the mass of its shell. Innermost shells are the smallest and are made up of heaviest particles. Outer shells are larger and consist of lighter particles. A proposed weak interaction of dark matter particles provides integrity of all shells. Table 1 describes parameters of macro object cores, which are 3D fluid balls with a very high viscosity and function as solid-state objects. The calculated parameters of the shell show that nuclei made up of DMF1 and DMF2 compose cores of stars in extrasolar systems. Shells of DMF3 and or electron-positron plasma around nuclei made up of DMF1 and DMF2 make up cores of galaxies. Nuclei made of DMF1 and DMF2 surrounded by shells of DMF3 and DMF4 compose cores of superclusters. Dark matter cores of macro objects. In WUM, cores of all macro objects possess the following properties. The nuclei are made up of dark matter fermions and contain other particles, including dark matter and baryonic matter, in shells surrounding the nuclei. Dark matter particles are continuously absorbed by cores of all macro objects. Ordinary matter, about 7.2% of the total matter, is a byproduct of dark matter particles' self-annihilation. It is re-emitted by cores of macro objects continuously. According to WUM, a rotational angular momentum of overspinning, surface speed at equator exceeding escape velocity, object before rotation fission is where G is the gravitational parameter, M is the mass of overspinning macro objects, R is its radius. These parameters are time varying. G is inversely proportional to tau, M is proportional to tau in power 1.5, and R is proportional to root square of tau. It follows that the rotational angular momentum of cos is proportional to tau squared. Nuclei and shells are growing in time. Size proportionally to root square of tau, mass to power 1.5 of tau, and rotational angular momentum proportional to tau squared, until they reach the critical point of their stability at which they detonate. Satellite cores and their orbital and rotational angular momenta released during detonation are produced by overspinning dark matter cores. The detonation process does not destroy them. It is rather gravitational hyperflares. Size, mass, composition, orbital and rotational angular momentum of satellite dark matter cores depend on local density fluctuations at the edge of overspinning dark matter cores. Consequently, a diversity of satellite dark matter cores has a clear explanation. Satellite dark matter cores are given off by volcanoes on prime dark matter cores erupting repeatedly. WOM refers to overspinning dark matter core detonation process as gravitational burst, analogous to gamma ray burst. In frames of WOM, repeating gravitational burst can be explained the following way. As the result of gravitational burst, the overspinning dark matter cores lose a small fraction of their mass and a large part of their rotational angular momentum. After gravitational burst, dark matter cores of prime objects, superclusters, and galaxies absorb new dark matter particles. Their masses increases proportionally to tau in power 1.5, and their angular momentum increase much faster, proportional to tau squared, until they detonate again at the next critical point of their stability. That is why dark matter cores of satellites, galaxies, stars, planets, and moons are rotating around their own axis, and dark matter cores of prime objects. Afterglow of gravitational burst is a result of processes developing in the nuclei and shells after detonation. In case of extrasolar system, a star wind is the afterglow of star detonation. Stars' dark matter cores absorb new dark matter particles, increase their mass proportionally to tau in power 1.5, and get rid of extra rotational angular momentum by star with wind particles. Solar wind is the afterglow of the solar core detonation 4.57 billion years ago. It is the result of ongoing and current dynamics within the sun. In case of galaxies, a galactic wind is the afterglow of the repeating galactic dark matter core detonations. In Milky Way, it continuously creates two dark matter Fermi bubbles. Formation of macrostructures, Dark Epoch. Dark Epoch started at the beginning of the world 14.22 billion years ago and lasted for 0.45 billion for the Laniakea supercluster. WOM is a classical model. Therefore, classical notions can be introduced only when the very first ensemble of particles was created at the cosmological time about 10 to the minus 18 seconds. At time much longer, density fluctuations could happen in the medium of the world filled with dark matter particles. The heaviest particles, DMF1, could collect into a cloud with distances between particles smaller than the range of a proposed weak interaction. As a result of the weak interaction, which is about 30 orders of magnitude greater than gravitational interaction, clumps of DMF1 will arise. They have random initial rotational angular momentum according to the equation, where Ri is the position vector of particle I with respect to the center of mass, and Pi is the linear momentum of particle I with respect to the center of mass. Larger clumps will attract smaller clumps and dark matter particles and initiate a process of expanding the dark matter clump, followed by growth of surrounding shells made up of other dark matter particles up to the maximum mass of the shell made up of DMF4 at the end of Dark Epoch. The process described above is the formation of the dark matter core of superclusters. Dark matter particles supply not only additional mass proportional to tau in the power 1.5 to cos, but also additional angular momentum proportional to tau squared, fueling the overspinning dark matter cores. We estimate the number of main supercluster cores at the end of Dark Epoch to be around 1,000. It is unlikely that all of them gave birth to luminous superclusters at the same cosmological time, being far away from each other. Luminous epoch. Detailed analysis of the rotational angular momenta of overspinning dark matter cores of macro objects before rotational fission showed that as the result of rotational fission of Virgo superclusters core 13.77 billion years ago, approximately 1 million galaxies like Milky Way could be generated at the same time. Considering that Virgo supercluster has grown inside out, in the present epoch, most old galaxies can be found in the middle, more recently formed ones on the outskirts. The number of generated galaxies could be much larger. As the result of rotational fission of Milky Way core 13.77 billion years ago, about 10,000 extrasolar systems like solar system could be created at the same time. Considering that Milky Way has grown inside out, old stars are in the middle, recently formed ones on the outskirts, our Milky Way is recently formed ones, the number of generated extrasolar systems could be much larger. Extrasolar system dark matter cores can give birth to planetary dark matter cores, which in turn can generate dark matter cores of moons by the same rotational fission mechanism. Luminous epoch is the result of explosive volcanic rotational fission of dark matter cores of superclusters and self-annihilation of dark matter particles. In our view, random explosive volcanic rotational fission of dark matter cores of prime objects looks like a firework of dark matter cores of satellites objects at the same time, so that the direction of the sum of satellites' angular momentum coincide with the angular momentum of the prime object. There are no preferences of directions of satellites' rotation at any level, supercluster, galaxy, solar system, versus random rotation direction. Dark matter cores of prime objects detonate at critical points of their stability, which principally depend on the accumulated rotational angular momentum. As a summary, the rotational fission of macro objects dark matter cores is the most probable process that can generate satellite dark matter cores with large rotational and orbital momenta in a very short time. Macrostructures of the world form from the top superclusters down to galaxies, extrasolar systems, planets, and moons. Macrostructures. Laniakea supercluster is a galaxy supercluster that is home to Milky Way and approximately 100,000 other nearby galaxies. It is known as one of the largest superclusters, with estimated by Bliss binding mass about 10 to the power 17 mass of the Sun. The neighboring superclusters to Laniakea supercluster are the Shapley supercluster, Hercules supercluster, Coma supercluster, and Perseus-Pisces supercluster. Distance from the Earth to the center of Laniakea superclusters is about 250 million light years. Please take a look at this figure too. This is a real picture of the world, with many superclusters and overlapping each other. The mass-to-light ratio of Virgo supercluster is about 300 times larger than that of the solar ratio. Similar ratios are obtained for other superclusters. In 1933, Zwicky investigated the velocity dispersion of Coma cluster and found a surprisingly high mass-to-light ratio, about 500. He concluded, if this would be confirmed, we would get the surprising result that dark matter is present in much greater amount than luminous matter. These ratios are one of the main arguments in favor of the presence of large amounts of dark matter in the world and validate the developed model of superclusters macrostructure. We emphasize that about 100,000 nearby galaxies are moving around center of Laniakea supercluster. All these galaxies did not start their movement from the initial singularity. The neighboring superclusters have the same structure. It means that the world is in fact patchwork quilt of different luminous superclusters. According to Turing et al., galaxies congregate in clusters and along filaments and are missing from large regions referred to as voids. These structures are seen in maps derived from spectroscopic surveys that reveal networks of structure that are interconnected with no clear boundaries. Extended regions with a high concentration of galaxies are called superclusters, although this term is not precise. Wang et al. In 2021 made a great discovery. Most cosmological structures in the universe spin. All the structures in the universe form on a wide variety of scales, from small dwarf galaxies to large superclusters. The generation of angular momentum across these scales is poorly understood. We have investigated the possibility that filaments of galaxies, cylindrical tendrils of matter, hundreds of millions of light years across, are themselves spinning. By stacking thousands of filaments together and examining the velocity of galaxies perpendicular to the filament's axis via their red and blue shift, we have found that these objects too display motion consistent with rotation, making them the largest objects known to have angular momentum. These results signify that angular momentum can be generated on unprecedented scales. In 2021, Lopez reported about the discovery of a giant, almost symmetrical arc of galaxies, the giant arc, spanning 3.3 billion light years at a distance of more than 9.2 billion light years away. That is difficult to explain in current models of the universe. The giant arc, which is twice the size of the Sloan Great Wall of galaxies and clusters, that it's seen in the nearby universe. This new discovery of the giant arc adds to an accumulating set of cautious challenges of the cosmological principle. Carr et al. In 2020 considered the observational constraints on stupendously large black holes slabs in the mass range more than 10 to the power 11 mass of the Sun. These have attracted little attention hitherto, and we are aware of no published constraints on a slab or population in the range 10 to the power 12 up to 10 to the power 18 mass of the Sun. However, there is already evidence for black holes of up to nearby 10 to the power 11 mass of the Sun in galactic nuclei, so it is conceivable that slabs exist and they may even have been seeded by primordial black holes. These latest observations of the world can be explained in frames of room only. Galaxies do not congregate in clusters and along filaments. On the contrary, cosmic web, that is, networks of structure that are interconnected with no clear boundaries, is the result of the rotational fission of dark matter cores of neighbor superclusters. Generation of angular momentum across these scales provide dark matter cores of superclusters through the rotational fission mechanism. Spinning cylindrical tendrils of matter hundreds of millions of light years across are the result of spiral jets of galaxies generated by dark matter cores of superclusters with internal rotation. The giant arc is the result of the intersection of the galaxy's jets generated by the neighbor dark matter cores of superclusters. The calculated maximum mass of supercluster dark matter core, about 10 to the power 19 mass of the Sun, is in a good agreement with the values discussed by Bliss and by Carr. In the future, these stupendously large compact objects can give rise to new luminous superclusters as the result of their dark matter cores rotational fission. 13.77 billion years ago, when the Laniakea supercluster emerged, the estimated number of main dark matter supercluster cores in the world was around 1,000. It is unlikely that all of them gave birth to luminous superclusters at the same cosmological time, being far away from each other. The 3D, finite, boundless world presents a patchwork quilt of different luminous superclusters which emerged in various places of the world at different cosmological times. The distribution of macro objects in the world is spatially inhomogeneous and anisotropic, and temporally non-simultaneous. Cosmological principle is valid for the homogeneous and isotropic medium of the world, consisting of elementary particles with 2/3 of the total matter. The distribution of macro objects with 1/3 of the total matter is inhomogeneous and anisotropic, and therefore the cosmological principle is not viable. The main conjecture of Big Bang model, projecting galaxy trajectories backwards in time, means that they converge to the initial singularity at T0 equals 0, that is an infinite energy density state, is wrong, because all galaxies are gravitationally bound with their superclusters. Big Bang never happened. JWST discoveries. The problem of ancient galaxies formation is a long-standing problem. The age of the universe is 13.77 based on the cosmic microwave background data. Astronomers believe that our own Milky Way galaxy is approximately 13.6 billion years old. Milky Way is one of the two largest spiral galaxies in the local group, the other being an Andromeda galaxy. Massive, mature disk galaxies like Milky Way cannot form so soon. Distances to remote objects other than those in nearby galaxies are nearly always inferred by measuring the cosmological redshift of their light. An important distinction is whether the distance is determined by spectroscopy or using a photometric redshift technique. The spectroscopic redshift is conventionally regarded as being necessary for an object distance to be considered definitely known, whereas photometrically determined redshifts identify candidate distant sources. For comparison with the light travel distance of the astronomical objects listed below, the age of the universe since the Big Bang is currently estimated at 13.787 billion years. Below, we discuss macroobjects with Z over 10. In Table 2 are presented the results for most distant galaxies with spectroscopic redshift determination. The most interesting is HD1, we will discuss later. In Table 3 are presented notable candidates for most distant galaxies. F200DB045 is the most interest in this group. The presented experimental results show that HD1 is one of the earliest and most distant known galaxies yet identified in the observable universe. HD1's unusually high brightness has been an open question for its discoverers. It has a significantly more luminous ultraviolet emission than similar galaxies at its redshift range. F200DB-045 is a candidate high redshift galaxy with an estimated redshift 20.4. If confirmed, it will be one of the earliest and most distant known galaxies observed. This galaxy would have a light travel distance, look back time, more than 13.7 billion years. Detailed analysis of observations of the first batch of candidate objects revealed by JWST is done by Yan in 2022. The summary of GW discoveries in the early world is: the most secure oldest galaxy is Glass Z13 that has already built up to 1 billion mass of the Sun in stars. The search of 88 candidate galaxies at Z over 11 shows that some of them could be at redshifts as high as 20. Some of those distant galaxies are strikingly massive, 10 times more massive than Milky Way. A new redshift record obtained for galaxy candidate Cirrus 93316 at Z16.7 with a stellar mass about 1 billion mass of the Sun. 7 galaxies with M mass more than 10 to the power 10 mass of the Sun and Z in the range between 7 and 11 were found in the survey area, including 2 galaxies with mass about 10 to the power 11 mass of the Sun. The stellar mass density in massive galaxies is much higher than anticipated from previous studies, a factor of more than 3 orders of magnitude at Z about 10. Extremely compact bright galaxies were found at Z in the range between 12 and 17. Super early, massive, evolved galaxies with blue spectra and very small dust attenuation. So much news. Warm explanation. These latest observations by JWST of the world can be explained in frames of room only. It is a question of time. The beginning of the world was 14.22 billion years ago. Dark Epoch, when only dark matter macro objects existed, lasted for 0.45 billion years. Luminous Epoch exists ever since for 13.77 billion years. Early galaxies formed in near-present configuration as the result of transition from dark epoch to luminous epoch due to the explosive volcanic rotational fission of overspinning dark matter superclusters cores and self-annihilation of dark matter particles. Ordinary matter is a byproduct of dark matter particles self-annihilation. There are no proto-galaxies in the world. That is why JWST did not see their images. Compact disk galaxies emerged as the result of the rotational fission of the overspinning dark matter cores of superclusters. Each of them have one dark matter core. There are no frequent mergers of galaxies at the early epoch. According to standard cosmology, massive mature disk galaxies with mass up to 10 to the power 11 mass of the Sun cannot form so soon because it takes billions of years to form them, and so should not be there at all at the beginning. We hope that oldest galaxies with high redshifts over 24, light travel distance more than 13.7 billion years, will be confirmed. It depends on the physical parameters of JWST. Disk galaxies. The experimental observations of galaxies in the world show that most of them are disk galaxies, which can be explained the following way. Galaxies emerged due to the explosive volcanic rotational fission of overspinning dark matter supercluster cores. As the result of this mechanism, galaxy bubbles created which have looked like chicken egg at that time. Yolk, spinning liquid dark matter core of galaxies with high viscosity composed of dark matter particles DMF1, DMF2, and DMF3. Yolk contains 1/3 of the total galaxy matter. Albumin, liquid interstellar medium with low viscosity made of DMF3 with dissolved other dark matter particles. Albumin adds up to 2/3 of the total galaxy matter. Membrane, boundary between interstellar medium and intergalactic medium with surface energy density sigma 0, where H is a Planck constant, C is a gravitodynamic constant, and A is a basic size unit. Extrasolar system emerged due to the explosive volcanic rotational fission of overspinning dark matter galaxy core and enter interstellar medium. As a result, galaxy bubble expands in the plane of the spanning galaxy's dark matter core and becomes a disk bubble. Conclusion. In the first presentation, I named three main pillars of room: medium of the world, dark matter, and angular momentum, which is one of the most critical problems in standard cosmology that must be solved. Hypersphere world-universe model is the only one cosmological model in existence that is consistent with the law of conservation of angular momentum. The described picture of the world is in fact a paradigm shift for cosmology. Astronomers have great achievements in investigations of macrostructures of the world. We are at the beginning of a new era of astronomy, cosmology, and astrophysics. Young physicists should be a part of it. They should concentrate their efforts on the development of a new cosmology and classical physics. I'm very excited about the future of physics. Acknowledgements. I'm always grateful to Academician Prokhorov and Professor Manenko, whose influence on my scientific life has been decisive. I am eternally grateful to my scientific father, Paul Dirac, who was a genius and foresaw the future of physics in a new cosmology. I am forever grateful to Nikola Tesla, who was a genius. I am much obliged to Professor Korda for publishing my manuscripts in the Journal of High Energy Physics, Gravitation, and Cosmology. I am grateful to Nick Percival for his useful comments and suggestions, which have led to an overall improvement of the presentation. Special thanks to my son Ilya, who helped me clarify the model and improve its understanding. Thank you so much for your attention. This is the end of the presentation.
Well, thank you very much once again, Vladimir. I'm actually almost drunken with all the information which you've provided, and I think if it's not too invidious to say that if we had to, if all the recordings of all the parts, the ones we've had already and the ones that are to come, were destroyed, and we had to select only one that could be retained, I think this might be the one. There's so much information here, and it's so fundamental to your whole ideas. So maybe if you permit me just to make a few observations, you might want to come back on one or two things which are almost questions. And then I see actually we have a number of questions coming in. Most of them have been comments, but we have maybe two or three interesting questions which I'll come to in a moment. Okay, so well, obviously it was important for me when you made the point that this whole question of there being an excessive angular momentum in regard to currently conceived ideas explaining the evolution of the universe, and you say this might be the only model that actually solves that problem, this so-called pollution problem. You know, coming from the original nebular hypothesis, which was popularized by the philosopher Immanuel Kant and so on. Now, this may come up a bit more in some of the questions, but I'm a little confused. You have this dark epoch, which would seem to precede the usually accepted date of the Big Bang, but you have an origin, if you like, of the universe in some form, 0.45 thousand million years before that, or wherever it is. So, and then you say the Big Bang never happened. So you might wish to address the point as to how you at the same time conceive of a beginning. You know, was that a sort of an evolutionary beginning without a sudden explosion? So that's just one thing. I was interested actually in the shells model, you know, the secretion of various shells, a bit like the Russian doll and so on. And maybe with regard, I'm sorry to put a few things on you, but I can come back to them if necessary. The rotational fission, would you say that explains the anomalous rotation of galaxies, where in conventional views they say, oh, well, we have to introduce dark matter to explain that? Those are just a few observations I've made. So you might want to make comments just on one or 2 points before we get to the questions. You know, the Big Bang vis-a-vis a finite beginning, albeit before the currently accepted view, and the rotational fission business.
Let me clarify the point of Big Bang model. First of all, from one side, at 13.77 years ago, it was like an explosion, firework of supercluster dark matter supercluster core. It's from one side, and you can name it as a Big Bang. But from the another side, Big Bang supposed that it was some initial singularity. And in my conclusion, I was against initial singularity, because all the existing galaxies They bound it with their superclusters. There is a patchwork quilt. That's it. That's why you can name this transition from Dark Epoch to Luminous Epoch like a Big Bang. But I don't like this word even, this combination of words, because was no Big Bang. It was a transition from one condition of the world to another condition, from dark matter epoch for 0.45 billion years to luminous epoch we live in. That's it. This is the first point. The second point, remind me what else you want to ask me about, because Big Bang model, this is the most acceptable right now model, but it is obsolete. It never discussed rotational angular momentum, orbital angular momentum, any angular momentum. You know, it is pollution. You're absolutely right. And nobody wants even to talk about it. It doesn't exist, and that's it. This is a science to forget about one of the most important parameters in even the spiral galaxies, you know, with a huge angular momentum, nobody even touching it. There is an experiment and there is no any explanation for it. As for nebula hypothesis, 300 years ago, genius people, they proposed something to explain how our solar system emerged. And unfortunately, up to now, there is nothing new, nothing principally new. We have the same ideas. Can you believe it? 300 years and nothing. People, they forgot about the problem at all. Nobody wants even to touch it. Nobody wants even to mention it. Thank you.
Right, they're frightened of that. So maybe Robert Kay has put the point I was hinting at in a more forceful way. He says, what's the difference between a Big Bang and explosion? You use the word explosion. I was going to say, so do you foresee that there was anything before your period, your first period of the Dark Epoch?
You know what? Let me tell you. No, there is none, because absolute age of the world is 14.22 billion years. It's calculated based on a G, on a gravitational parameter value, on my model, and so on and so on. It's absolute age. There is nothing before. But what is important, right now in literature, there is a lot of discussions about some period in the evolution of our world before Big Bang model. You know, there are a lot of talks about, there are different models trying to explain that something was before. And I am the first who started to talk about in 2018, 6 years ago. I told, guys, there is a dark epoch. We don't know about it because it is made of dark matter only. I mean, not dark matter only. The medium was with some ordinary particles, but dark matter macro objects, this huge dark matter cause that they will explode. And why explode? Because it's a volcanic process, volcanic. On prime objects, suddenly you have volcano, and then all what you have around this huge volcano will be as galaxies. Then galaxies will produce extrasolar systems, planets, moons, and all this stuff. It's a firework. Did you see any firework in the sky? Many times I saw it, and it's exactly what's going on. And why it is dark matter cause? Because they behave like a solid state bodies. You can transfer your rotational and angular momentum to rotational and orbital momentum for satellites. It's exactly what was not done by solar fission model. There were gases, planets, gases, solar system. There was no dark matter. Dark matter is a savior of this solar fission model. Can you see that I use existent models, model of lunar fission, of solar fission, and so on, but I put a new core issue, core notion, dark matter, solid dark matter balls that you can transfer your rotational momentum to angular and rotational momentum of satellites. That's it. I'm trying always to use some classical work before myself and to improve, to increase, to upgrade to the real picture.
Yeah. Okay. So I was going to suggest that just prior to getting to the questions and then inviting people coming in, my last point was about your view of the rotational curves of galaxies and the conventional suggestion that they had to introduce dark matter to explain that. Franklin Hughes put that in as a question as well. Same point, I think. Is your dark matter a different thing than the dark matter responsible for galactic rotational curves? If so, aren't you causing confusion? Well, my point was simply, what do you think of their conventional statement that you need to introduce dark matter because of the anomalous rotation of galaxies vis-a-vis
No.
Newtonian?
I made a conclusion that there is no need in dark matter to explain rotational curves. There are two possibilities. One I made in my presentation before. The other one, I'm thankful to Franklin, who referred to the work of the Hilster. And I looked through, it's valuable, and it might be or one or the other one. But what is important, my conclusion, there is no dark matter in the outside, in a hollow of galaxies. There is none. All the dark matter is inside of dark matter cores, including, by the way, our Earth. Inside of our Earth, there is a dark matter reactor. It's exactly, we live on the same surface of this dark matter core, like a dark star inside of our Earth. That's it. That's why, please, dark matter in my system is inside of our macro objects and in the medium of the world. Of course, in the medium of the world filled with ordinary matter, ordinary particles, and dark matter particles too.
The words dark matter can raise hackles among many of dissidents, so on. So Franklin just goes further. He said, you mentioned De Hilster showing dark matter not necessary. Isn't what you're proposing another ether, not a DM mentioned by mainstream? One might suggest that using another form of phraseology might be less likely to cause confusion because of the difference between your concepts and the mainstream concepts of dark matter, and yet using the same words.
Let me tell you about the ether, because it's very important to say about the difference between my medium and ether. Ether, and in general relativity, by the way, it is named perfect liquid. There is no ether in my model. There is no perfect liquid. What kind of liquid you can talk about in the surrounding medium if the concentration of protons is 1 proton per 4 cubic meters? It's a rarefied gas of different particles. That's it. No ether as a liquid, perfect liquid, whatever. It is the medium like a gas. In our air, we have some gas around us, composed of different particles. The same story in my medium. It is rarefied gas of all these particles. There is no connection to ether or to the liquid, perfect liquid, whatever.
Right. Very well. Thanks very much for that explanation. I just wish to spend another few minutes. As usual, time is running out on us, and I did encourage you not to rush anything, and I'm delighted I did that, actually, because you covered so much today. But I'd like to cover a few more questions, which I see have come in just before inviting people in the green room to come in. So at the beginning of the session, there were mainly comments just between the participants, but there are a few questions that came in later. Okay, let me just see. Some of these are comments. Yeah, Franklin has already given the question that we've addressed. Stephen Gift actually has asked, can your model explain galaxy redshift with distance? So the redshift, which is normally stated to be a Doppler shift, you know, and other people like myself, for example, would explain it by you know, more tired light type phenomenon. I mean, does your model deal with that?
Let me talk about tight light model, because it's very important to see what is going on. First of all, redshift, it's experimental results, it's astronomy, and I believe in it, and that's it. I'm not in charge of redshift, all of the galaxies, and so on and so on. There is some very strange for me idea about the expansion of wavelengths during photons traveling through the world. Wavelengths is the classical notion. It belongs to an ensemble of photons. No one photon have a wavelength. Each photon has only 4 momentum. That's why tight light, I don't understand what does it mean. The same story with microwave background radiation. The same explanation like tight light, and then we can see photons now in microwave background radiation that was irradiated 380,000 years after the Big Bang. Absolutely wrong. Photons, they don't have wavelengths. To have some homogeneous and equilibrium between photons, we must have some body, some bodies, some ordinary matters that photons will interact with it and homogenize and make an equilibrium with the bodies. In my model, my microwave background radiation is the result of interaction with intergalactic plasma. That's it. Without intergalactic plasma, you cannot change the wavelengths of your photons. They don't interact with each other. They don't have wavelengths at all. What we are talking about? There is no tight light at all, because tight light, it's a photons with wavelengths, but there is no wavelengths for photons. An ensemble of photons, it's a different story. It's a classical notion, and to achieve this variable wavelength, you must have interaction with some body, and this body in my model is plasma, intergalactic plasma. That's it. That's why
so you do envisage a material influence, let's say.
Yes, you must have it. You know, by definition, photons, they cannot change anything before they will change. They have some interaction with somebody. In my case, it's intergalactic plasma.
Franklin, he sort of asked earlier, oh, maybe the whole thing is a misconception of angular momentum and so on, and one might not know that. But he then said, how do you explain that Jupiter has 60% of the solar system momentum?
It's simple, you know, all the planetary system of solar system was generated, emerged at the same time, when sun has much more. I mean, all this solar system rotational angular momentum was inside of the core of the sun before explosion, before rotational fission. That's why Jupiter has as much as it has, and all the rest, all together, all this rotational and orbital angular momentum of the whole planetary system was concentrated in solar dark matter core.
Okay. Yeah. So some of these we've actually discussed already. Okay.
Thank you so much. I'm very excited about the questions, because it's everything principally new, and it helps me to understand my model itself. You know how it works for people.
Yeah, I find the same. I love people posing questions to me, which checks my
yes.
ability.
It's exactly what I'm doing right now.
Yeah.
I want to hear the questions about my model and the difference between my model and existing models. They should be killed. Nobody even tried to answer
Yeah.
the questions about
And
angular
I was thinking also, prior to the origin that you conceive of, where these particles of which dark matter is composed in your model, were they still in existence? And Cornelis has put it down. He said, did dark matter particles form or evolve, or did they always exist? So that's basically the same thing as I was thinking of.
Yes, yes, yes. You know what? In my previous presentation, that's why we need to go at least 2 weeks between, because for 1 month we forgot about my results, the previous presentation. Our dark model, dark particles, they created by universe continuously. We have all the time matter coming to our world. Who is the creator? The universe. That's it. Or every second, every minute, we have new matter in our world. That's why it doesn't exist. On the contrary, I told that the beginning of the world was 10 to the minus 18 seconds from the beginning. And then the very first ensemble of particles were created. And then were new, more, until superclusters, dark matter cores, after Dark Epoch. 0.45 billion years. You see, 500 million years we have extra right now to develop our future luminous epoch. And by the way, a lot of people right now talking about that in our world existed before Big Bang model. It's a new idea for them, but it's not a new idea for myself. 6 years ago, I told about.
Okay. Well, there are a few more just elaborations from people like Franklin and Stefan on what we've said already, pointing out redshift and things like that. So perhaps we've dealt with those for the moment. If there's time at the end, we can come back. Maybe there's one more. Let me just see what he said at the end. Is that you can never detect your dark matter or even... Well, I don't know. It's a bit of a philosophical thing. Franklin said, isn't the biggest problem with WM is that you can never detect your dark matter particle, even if you had all the resources in the world.
Let me remind you the previous presentation. We never can detect neutrons. We cannot detect our neutrinos. We have indirect observations of them. Why we accept neutrons and neutrinos without any proof, confirmation of their mass? Why our dark matters, they don't have charge. That's why you cannot prove their existence by direct experiment. By indirect, supposedly, these superclusters, dark matter cores, the ratio of mass and light is 500 times different than the ratio for solar system. How to explain it? And Zwicky, by the way, 91 years ago, told already about how much dark matter we have as a center of superclusters. Yeah, I use the existent ideas from the history of the physics, of classical physics.
Which makes it very attractive, certainly from my point of view, rather than just introducing ad hoc hypotheses. But James Keane, you mentioned earlier, that your model was unique insofar as you could see it, in that it conformed with conservation of energy. But James has come in and said, so there is no conservation of energy. So maybe with your permission, Jim, I could bring you up just to elaborate a bit more on that to Vladimir. Or say anything else you want, indeed.
Yeah, well, thank you, Vladimir, for your scholarly approach to reviewing and trying to understand recent literature in cosmology. You're a quite thorough scholar, if I may say so. One question I have is, what if angular momentum is not conserved? Newton's rules state that linear and angular momentum are separately conserved, whereas the inertial propulsion phenomena, which I've looked at and others have described as well, show that precession, which is a translation or a linear momentum event, can result from angular momentum. And so therefore the two are somewhat interchangeable. Yet it seems that repeatedly through your presentation, you cite the possibly mistaken idea that angular momentum is absolutely conserved. Um, so how do you deal with that possible exception?
First of all, you're absolutely right. I'm not supposing. I believe that angular momentum has a conservation law. That's why you cannot create any big, especially big one, angular momentum without angular momentum. That's why nebula hypothesis, even this hypothesis, suppose that there is a big, huge cloud with certain amount of angular momentum. You cannot rotate your sun and planets without existence of at the beginning of rotational angular momentum. It's my point too. The second very important point, as I mentioned in my model, the very first initial angular momentum can be emerged as a result of linear momentum of surrounding particles. I show that when it will be clumped, then all these molecules that will be in clump, they will concentrate their linear momentum in angular momentum, but it's averaging for ensemble of particles. Any particle with linear momentum cannot transfer this momentum to angular momentum. No. Only ensemble, when you have the very first clump, and this is a classical body, you can get the very first angular momentum. And then all the rest dark matter particles will be absorbed by this clump. Inside of this clump, it will be generation of a huge linear momentum. And according to the rotation, against rotation, it will be different for different particles. Then you will accelerate your rotation of the existing already clump. But the first clump and the rotation axis of this clump will be random. We don't know how they will play together, these surrounding particles, how they will create all their overall angular momentum for the clump. That's it. But this law it works. It works, no doubts about it. You cannot rotate something without initial angular momentum saved in some place, in some body. I'm 100% sure.
Jim, anything else you'd like to respond to or say before we?
Well, I'm not sure I got a satisfactory answer in the sense that here we're talking about particles with linear momentum clumping up, and this winds up as a angular momentum event, or on the other hand, the reverse, I guess, the explosion or fission, I guess, that you talked about, where something that is rotating then results in the ejection of particles, which would presumably be seen as linear momentum or translational events. And therefore, there would be some exchange between the two types of momentum, as the inertial propulsion phenomena seems to indicate. So all I can say is that I'm remained a little bit confused as to actually what your position is on the matter.
Let me tell you that even in your comments, you told that by volcanoes, you emerged some rotational bodies that they will transfer them to linear momentum. I'm asking you the question, why they rotated? All these balls out of the volcanoes. Where they came from, what the rotational angular momentum, where they got it. And the first one. The second one, there is a little bit transfer
What
from
was
angular momentum to linear momentum. This is so named.
A bit of a chicken and egg situation as to what came first.
Well, the first, of
Angular.
course, even in comments, the first is angular momentum of the bodies extracted from volcanoes. You told exactly this point. And my question is, what is the first? Where did you take this rotational angular momentum for the bodies out of the volcanoes? Who? How? I don't know. My understanding, of course, let me finish. There are some transfer linear momentum. It's so named wings, galaxy wings, these solar wings, extra superclusters wings. Of course, the particles along the rotational axis will leave this rotational ball directly to the along to rotational axis. That's it. There is some transfer, but it's a minor. Solar system, we have some solar wind. Yes, there is some transformation, but the original is rotational angular momentum of the core, and only particles along the rotation axis will live with linear momentum only, because they produce during self-annihilation inside of rotational body, and they will live along the axis without any change of their momentum. The generated angular linear momentum is not transformation. It is the result of self-annihilation of dark matter particles. Because gamma
well?
quants
Again, we have another term which
have
is
this-
undefined. What self annihilation actually means, and does this violate the conservation of energy? Yeah. Anyway, in a nutshell, my suggestion might be that since you do seem to recognize the possibility that angular momentum is not 100% always conserved and can be converted to linear momentum, in what you just said, you might want to drop this idea of the law of the conservation of angular momentum, which appears so much in your papers. Because what you're actually saying contradicts that, I think. Thank you. There are other
I'm
questions.
very sorry. I'm
so
very sorry.
I'll
You
defer to
misunderstood
others
me.
here.
I am sorry. You misunderstood me. I told you that linear momentum has particles got generated inside of rotating bodies as a result of self-annihilation. It is not connected to angular momentum at all. It is the result of the gamma quants created inside of the rotating bodies. That's it. It's two different, phenomena. One of them angular momentum, another one self-annihilating of dark matter particles and creating of linear momentum along the axis of rotation. That's it.
So this whole concept of momentum, and specifically angular momentum, which has been central to today's presentation, you gentlemen may wish to discuss this further offline. And unfortunately, we are really running out of time, and we haven't had people coming in. So is that all right for the moment, Jim? You can give it a little.
Oh yes. There are other people who have other questions. Thank you, sir.
Thank you indeed. And
thank you for the question.
Yeah, no, it's always a good question. But I just like to say that, there are many people, and I don't exclude myself from it, for whom some of these concepts, and you might be using some words which are very similar to the concepts which are used in the mainstream, are a bit like a red rag to a bull. Now, David Hilser has put this very strongly. We talked about terminology a moment ago, but he said the word dark is the canary in the coal mine that screams something fundamentally wrong with modern cosmology. It does not exist. It is an artifact of a failed theory. So it's almost like a paradox or something like that. David has put that strongly. And Franklin has come a bit talking about ad hoc and so on. But you did, of course, refer to Feynman's principle, and you did concur with it. It doesn't matter how beautiful the theory is, but one has to bring out things which are contrary to experience. There was one other question I want to deal with before inviting more people to come in the green room. It's by Wes Johnson. He says, does WUM explain the apparent chiral nature of our universe?
I'm sorry?
I presume what he means is like our universe has a chirality, like a right-handed system or a left-handed system. And does the WM in any way deal with that, or have you looked at it at all? No, okay. It might be something from the future that could be looked at. Thank you for your question.
For the future, but my model is a hypersphere, homogeneous, isotropic, and medium, and so on and so. There is no right and left-handed any macrostructures, whatever, It's homogeneous and isotropic, medium and anisotropic, and inhomogeneous distribution of macro objects, luminous macro objects.
And Jim Morrison again has referred to the ad hocness of the Big Bang theory, but you don't accept Big Bang. You just accept something which some of us might consider related
know something. We must cancel it. We must reject it. It's obsolete theory. It doesn't work at all. Look at Richard Feynman words, and that's it. Simple like this.
Okay. Now, if there's anybody, I'm going to bring you in the time available, gentlemen. The only men here, I think. If anybody wants in immediately, just wave your hand. Okay. Now, I don't know if Cornelis is available. He's logged in and he's put a question in. So there he is. He just clicked on. So he says, why so many different dark matter particles, and what are their differences? So Cornelis, you might want to address that question and maybe be as brief as we can, so we can get others in.
Well, I was just observing that. Yeah, I was just observing that he was mentioning different G versions of G dark matter particles, G number and G in numbers, and I don't know if he went through and explained what the different G's are, or what the difference between dark matter particles are. But it seems like they're not all the same particle characteristics. Obviously, there's different ones. So I was just wondering why so many different particles.
Yes,
it kind of goes along with the evolution of the particles that I was asking earlier. He says that they do evolve, or they do come into existence. The universe is constantly making them, but there's no real explanation as to how they're made, what their properties are, other than dark mass characteristics. So that was basically my
properties
question.
of what? Properties of what? I misunderstood the last your point. Please repeat it. Okay.
Well, you have different dark matter particles.
Yes, I will explain it. And then the last your comment, I missed it. Sorry.
And that was basically the question. What is the difference between the dark matter particles, and how are they created? Because you say they're created at the very beginning by the universe. They're constantly being created. But what process is it that creates them, and what process is it that makes them different?
Okay. Now it's two parts, and it's a very important question. Thank you so much for them. First of all, in my previous presentation, I showed all these dark matter particles, and of course, they are different. They have different rest energies. How to find them? It's very simple. I have a basic energy unit, and all of them have a constant rest energies, and all of them, they're different by value of alpha in different power. Alpha 0, alpha squared, alpha in 4, alpha -2, and so on and so on. That's why all these dark matter particles have the same energy, basic energy, rest energy, multiplied on different value of alpha. Alpha is a dimensionless Rydberg constant. That's it. The second point, creator. Creator is the universe. The universe has no any properties. There is nothing we can put into this creator as a physical properties. No, you can see it like a God. God creates our dark matter particles in our world by some mechanism. We have no idea about it. We don't know how to name it. And what is important, universe creates dark matter particles in the 4D ball, in 4-dimensional ball, and we are only the surface of this ball. That's why it is a very complicated issue. It's a very complicated question. But as for me, we have no questions to universe. There are no physical properties of this. I don't know how to name it. It's universe. It's universe. That's why I left this word universe for creator only. There is only one property of this universe: creation of dark matter particles. But it is not from the beginning. It's continuously creates. Continuously. It's not as a Big Bang. You have all the matter and then exploded this matter, and you have all this observable, even non-observable universe. No. In my case, there is continuous creation of matter by universe in the 4D ball. I meant in nuclei, and the hypersphere surface will live on this 4D ball. That's it.
But do you conceive, Vladimir, and I hope I haven't missed anything here, do you conceive of dark matter as being analogous in atomic constitution to ordinary matter? Or do you think...
Oh my goodness, it's a perfect question. Oh my goodness. I expected it, man. You're absolutely right. And what is important, I propose so many different dark matter particles for two reasons. First of all, to explain the difference in different our macrostructures. You see, for extrasolar systems, it's enough two of them. You want to have a galaxy, you have to use another one, the third one. You want to go to superclusters, it's the fourth one, and so on and so on. That's why, it's not because I invented them. I put them to explain the existent variety of macro objects. And the second point is the gamma quants. You know that our world is filled out with all the gamma quants, with all the range from 0.3 electron volts to more than 1 tera electron volt, and so on and so on. And there are huge spectra. And what people they are doing right now, they're looking at this spectra and trying to guess what kind of dark matter particles can create this, spectrum. But if you have spectra very broad, from 1 electron volt to tera electron volt, you cannot put one particle to explain them. That's why you need some sequence of particles, and then you can approach to have an approach of your spectra you experimentally measured, and you can apply all this system of my dark matter particles in sequence one by one. In my presentation, the previous one, I told you about it. And then you can approach this overall spectrum, gamma spectrum of the world with different dark matter particles in the right place. And you can then, specify gamma quants with gamma quant spectra with only, there are such a dark matter particles, this is a number of it, this number. You can approximate any gamma quant spectra with sequence of different dark matter particles, self-annihilation.
So it's work in progress.
It's like the possibility to do very good job with iteration of gamma quants, gamma spectrums. You can iterate them with existent dark matter particles and to find how much of these dark matter particles you have inside of this gamma spectrum.
Okay, but we need more work in order to answer the question definitively. Basically, I think you're probably saying analysis of spectra and so on. Okay, well, now we're running out of time. I'm wondering if Nick Percival, whom you acknowledged in your speech, and I know has made a number of comments on all these various parts, if he wants to make a brief comment. Nick, you're on stage now. I don't know if you want to add anything. I know you've been discussing all this with Vladimir.
Thank you, Ian. I do want to say thanks very much to Vladimir for another great presentation. And we are going to have 8 of these. And as Ian says, we're kind of reeling at the end of this one. And then we magnify that by 8 times. It shows what great work you've done. And I'm very impressed by the fact that, I think Ian may have mentioned this earlier, that it's really empirically driven rather than someone doing mathematical manipulations or sitting in an ivory tower and coming up with some conceptual ideas. I'll just enter one very naive question. Since there's so much more, let's say about 9 times as much dark matter than ordinary matter, it seems like there should be rather dramatic evidence in terms of gravitational effects, like when 2 galaxies come together, and are not separated that much. The fact that they contain 9 times as much mass as previously envisioned in Newtonian times, that should be reflected in how fast they approach each other. Do you have any comment on the empirical evidence of, there being 9 times as much mass as we used to think about in the universe?
Yes, of course. Thank you so much. It's a very good question. Let me remind you about 2 already binary galaxy systems revealed by experiments.
Yes.
It's very important. It was some excuse that we have atomic hydrogen 21 centimeters and so on and so on. It was absolutely wrong. I explained the 21 centimeter radiation by xions, particles, and their interaction with each other. What I mean right now, even the galaxies, dark galaxies with 21 centimeters, composed of dark matter only, and they have a mass, calculated mass, equal to galaxies. 2 samples already, experimental samples, of existence of dark galaxies as a pair of binary system with luminous galaxy. That's why, as dark galaxies was 200, 300 years ago, right now we have a dark galaxies, and it's experimental result. The second very important point, many times, dark matter, how to prove that there are some huge dark matter objects. First of all, gravitational lensing. So many gravitational lensing right now we have from nothing. There is nothing between some source of light and us. Nevertheless, we can see some lens effect. How to explain it? And then the next one, we have something like in our Milky Way. We have center dark matter. I will talk about it in one of the next presentation. And we know that some stars going around this dark matter core. It's a black hole and so on. I will tell you next time about this black hole. There is no black hole in here. But the behavior of the stars around this dark matter object depends on the mass of it. That's why you don't see each particle of it, but you know that there are some objects. You can see the behavior of luminous objects around them, or you can see by gravitational lensing only. Simple like this. That's why, it's a very good question. And I'm so happy to open right now a new era in binary galaxy systems, including one dark galaxy with mass, calculated experimental results. Thank you so much for the right understanding of my model. It's based on experimental results, not on some deep fundamental mathematics, equations, and all this stuff. No, I'm trying always follow the experimental result and trying to explain them in frames of my model. I didn't develop theory. I didn't put all these equations you need to do in the future. Always I name only model, means ideas. And I try to use ideas from history of classical physics and to develop them, to apply them in frames of my model.
Thank
The
you.
last one, Nick,
And
thank you so
we look
much.
forward. We look forward very much to your continued participation, Nick, and others in the next 5 parts, and we'll come back to many of these questions. So thank you for raising those points, Nick. And the last point, if I may, is Franklin has made a number of comments. I think we probably don't have time to go into them now, but you know, he's pretty critical of things, and which is fine. And he's asking things like, I mean, has your theory has dealt with things we know already, and perhaps I'm paraphrasing what he's saying, and perhaps been in consonance with those, but has it predicted anything that we haven't known? You know, and then made any prediction of that nature, and you know, again, he's coming back to the whole question of the dark matter and maybe ad hocness and all that thing. So perhaps we can come back to these, you know, in the next lecture or two, because they're important points. You've made, yeah, okay. There are other points coming in about Dr. Henry Dowdy and gravitational lensing and so on. But I think really Cornelis has come back. Model of quantity of energy density in space and curvature of space and time. Yeah. Okay. So I dare say some of the elements that you've been talking about, insofar as they relate to things like redshift and you know, the origin of the universe and hypotheses and all these sort of things, they'll emerge again in the further parts of your talk. You know, we will be dealing with the next one. So perhaps rather than start getting into a further conversation about things which we have only briefly touched upon today, I'll just invite Vladimir to say a few words in closing, if he hasn't sufficiently dealt with that, and then I'll come in and I'll officially close the meeting. So Vladimir, a few more minutes if you wish.
Yes, I wish. First of all, I would like one more time to say how much I am thankful to Nick for his recommendations about my presentations. I will tell you why. Because when he read my presentations, I have text of my presentation, I presented it to you today. He told me, Vladimir, you have so much that if you will not read your text, nobody will understand anything, because everything principle in you. I know how it's difficult to take new approach, new model, new ideas at once. And I try to concentrate all the ideas around angular momentum in one speech for 1 hour only. Of course, I didn't present all the results, all the information about it, because it is impossible to do it. I'm developing this model for 23 years. That's why I collected so much information. I developed so many different different ideas of my model. That's why, you know, it's very difficult to put all these results in each presentation. 8 of them, even 8 of them, will show only some results of my investigations. But what is the most important? I will tell you. I am trying always to follow experimental results. Whenever JWST was published, the very first results, immediately I answered the proper paper and I wrote why we have right now so well evolved galaxies at so early after Big Bang. Because we have extra 500 million years before this transition from Dark Epoch to Luminous Epoch. And that's it. Simple like this. And there are some dark galaxies. It was such experimental results. Immediately, I published the papers about dark galaxies. I'm trying always to hold my hands on experiments, because I'm absolutely sure we have a new era of astronomy. But to use models, theories developed 100 years ago without any astronomical observations. It's absolutely wrong. They were good 100 years ago, but now we should obsolete all our Big Bang models and all the other models because they were developed 50 years ago, 100 years ago, 300 years ago. It's enough. Right now, we are on the border between existing classical physics and new cosmology, new physics. And I'm so thankful to Paul Dirac, who 86 years ago predicted this transfer from nucleus to new classical through new cosmology. He told, please go to cosmology. You will find so much new. Then you will go to classical physics on a new platform. By the way, my last 8th presentation will be about classical physics. I will talk about what should be changed in the frames of the classical physics too, because of this model. Thank you so much for great questions. It was very important for me to think about them, to be prepared for the next sessions and the next series of questions. I hope that you will think about my presentation. You can read it one more time carefully and slowly, stopping this YouTube, rolling, and so on and so on. Thank you so much. For my pleasure to be with you, to tell you the first time about angular momentum problem, which one is the most critical, and nobody told about this problem, and nobody solved the problem with conservation of angular momentum. Thank you.
Well, thank you so much. And Vladimir is based in the west coast of the United States. He has to get up very early on a Saturday morning to give us these talks. I have it very easy. It's 3 p.m. here in the afternoon. I can relax and do things on Saturday morning. So we're very grateful to him, as I've said on previous occasions, for having devoted all these weeks, going into the summer to give us the 8 parts. We've had 3 parts yet. And I did perceive as well what I think he's validated, that this is perhaps the most important part. He's gone into so much detail on this essential question of angular momentum conservation, and all the ancillary questions which I have and others have. I mean, notwithstanding those, it's been a very comprehensive talk today, and we'll be able to return to a lot of these issues later on. And as Vladimir says, I mean, these questions, even putting it up to him, is actually, very positive from his point of view. It's actually informing what he's going to say in the next 5 parts to a certain extent, and we'll be able to, pose these questions further to him. I know Franklin has put it quite strongly, and David as well, and so on. I have some points as well. We can discuss those, but I think. Luckily, we'll be able to revert to this in the next fortnight. Well, I know it's not the next week, but we don't have a month between the 2 lectures, so we'll be able to remember what Vladimir has said today, and most importantly, look at the lecture again today. I think I'm going to have to do that myself. I'm going to have to go through maybe quickly and maybe stop the recording at some points and go on. So I'm keeping my fingers crossed that the jinx we had 2 weeks ago has not reoccurred, and I think it should be resolved. Actually, we should have the complete 2 hours today. So thank you all very, very much. I noticed comments weren't coming in on Facebook today. They were coming in on YouTube. I'm a bit surprised about that. They're normally mixed, so there might be some reason for that. But anyway, it's all continued to the end. There are questions coming in now which we don't have time to deal with, I'd like to thank you very much for coming in on the social media, some of the regulars, and also people we haven't seen before. I see there's a person logged into the green room. No, he's gone now. I didn't recognize his name. Sorry I didn't get an opportunity maybe of talking to all of you, but thank you all in the green room very, very, very much for your contributions. I'm going to wish you all a very, very good day. I hope Vladimir will be able to use his day in a positive way now. I have a few things to do today, but it's late now, and we look forward to seeing you. I think I can validate at this stage that in 2 weeks' time we'll have Vladimir coming back with part 4 of this series of talks, and we'll then after that be halfway through. So thank you all very, very much for your attention, very much for your participation, and very much for your questions and your hard questions. That's what we're all about here in the CNPS. We're not shy of debate. We're doing it all in a very mannerly way, but pose the hard questions by all means. So I'm going to stop the stream now, and I'll wish you all, wherever you are, if it's still morning, good morning. If it's afternoon, good afternoon. If you're in the east, if it's evening, good evening. I'll wish you all goodbye, and thank you once again.